More than 20 years have passed since Steven Spielberg's Jurassic Park blockbuster hit the big screens. And in that time, a new wave of discoveries has contradicted the images that come to mind when we think of dinosaurs. The bulk of evidence now suggests that nearly all carnivorous dinosaurs were covered in feathers. Even the mighty Tyrannosaurus Rex.
Perish the thought.
No. But with the fourth Jurassic Park sequel set for release next year, the film's director has already ruled out the prospect of feathered dinosaurs. It does make them slightly less scary.
It'd look like Happy Feet 3 if they did that or something like that. Anyway, Australian Geographic editor John Pickrell has spent the past 2 years researching the latest discoveries of the Jurassic Age and has just launched his book titled Flying Dinosaurs, which details how fearsome reptiles became the birds in our backyard, with a little bit in between. He joins us now in the studio. John Pickrell, thanks so much for coming on in. Okay, before all of this, I understood dinosaurs to be huge and scaly and fairly nasty and frightening in a lot of cases. Birds are feathery and quite lovely and you can put them in a cage, and never the twain shall meet. We're going to have to rethink this, aren't we?
Well, all of the discoveries over the last 20 years have really totally changed what we've thought about dinosaurs. So there was a dinosaur called Sinosauropteryx, which was discovered in China in 1996, and it showed us for the first time that many dinosaurs had been feathered. And it was a big shock when we found that fossil, because people were just not expecting to be able to find feathers on dinosaur fossils. They had some idea up until that point that dinosaurs and birds were closely related, but they were not expecting to find feathers on a fossil.
But suggesting that, say, a T-Rex would be similar to a chicken, I'm just trying to picture the feathers here. I think you're going into some dangerous ground here.
Well, it depends a little bit on the size of the animals. We think that most small carnivorous dinosaurs did have feathers because they've now found about 40 different species of feathered dinosaurs in China.
Got some on now.
Yeah,
just
exactly. So that's Microraptor. That's called Epidexipteryx. So there are a range of different animals, and some of the feathery coverings would have been more for insulation, so that it wouldn't have quite looked like how birds look today. It might have been sort of fluffy, downy, fuzzy covering, but some of the larger dinosaurs may only have had feathers when they were young, or they may just have had sort of small amount of feathers for display or insulation. So, and we know also that many of the herbivorous dinosaurs definitely had scaly skin. They didn't have feathers. So it's a bit of a mixed bag, really.
So, paint us a picture. What did the world look like 150 million years ago or thereabouts? I'm not implying that you were around back then, of course, John. And what roles did the feathered dinosaurs play?
I mean, they're the same carnivorous dinosaurs that we've always known about. They're big, scary animals. It's just that they would have had, fluffy coverings of feathers. And we know that some dinosaurs now, such as Velociraptor, they'd actually have had long flight feathers on their forearms. So in effect, they would have had small wings. So some people are sad that dinosaurs have feathers now, and they think it makes them a bit less scary. But I think it actually opens up a whole new opportunity to reimagine dinosaurs as brightly coloured, fantastical, interesting animals. And they probably had these feathers for display purposes, and it's a bit more interesting than sort of green, grey, scaly-looking animals.
That's true. It also proves you should never judge any creature by what they wear.
That's right. And undoing the myth, we're not going to find any dino DNA in fossils.
Well, it seems pretty unlikely. There is some ancient DNA in fossils, but it's not really been found in fossils that are much older than 50,000 years old. And the largest non-bird dinosaurs became extinct about 66 million years ago, so it's a huge gulf of time. So, but we don't actually have to look to fossils to find dinosaur DNA, because birds are dinosaurs. So birds are full of dinosaur DNA anyway, and that birds may have genes hidden away inside them that, once coded for dinosaur traits, and they're just switched off now. So there's actually a project in the US which is looking at developing chickens and seeing if it's possible to turn back on some dinosaur traits again.
Let's talk a bit more about that. And it almost sounds like a new instalment of Jurassic Park, but this thing, Evo Devo, what is Evo Devo, and tell us how it does relate to the possibility of recreating a dinosaur?
Well, it's looking at the development of embryos, and it's looking at how traits from evolutionary history might actually be kind of repeated when you watch the development of an embryo. So if you look at a chicken embryo developing, at one point the animal has a long tail, it has teeth, it has claws, and its wings are actually arms. But then these are lost in later later stages of development. So these researchers in the US at the Museum of the Rockies, they're actually wondering whether it might be possible to stop some of these things disappearing again, so that you're actually able to produce a chicken that has a long tail, maybe it has claws and teeth. Yeah,
It's terrifying.
And so what's Evo-Devo actually mean then? What is that concept?
it's evolutionary developmental biology. So it's studying the evolution of the sort of developmental process of the embryo.
So when you
Yeah.
say this is the golden age, is that what you're referring to, or are you...
It's the golden age of dinosaur discovery at the moment, because as you were saying before, Jurassic Park came out 20 years ago. I mean, what we've learned in the last 20 years is a huge amount, and it dwarfs what we ever knew before Jurassic Park came out. So really, most of what we've learned about dinosaurs we've learned since Jurassic Park came out.
So you must be disappointed that they're not going to have feathers in the new movie. But again, obviously it's sparking international interest in this field, and then I guess driving research dollars.
Yeah, certainly, and it is disappointing that they're not going to have feathers, because it doesn't reflect the true science. It really doesn't reflect everything we've learned over the last 20 years. But it's exciting, nevertheless, that there's another Jurassic Park film.
You never know, they might make a romantic comedy musical with feathered dinosaurs, John. Can I ask you more broadly, as we're talking about learning here and new developments, new discoveries, and learning about ourselves, where we're from, or where the Earth's from, with funding cuts to scientific research bodies and more generally changes to higher education and the potential, or the feared potential, that it might put off prospective students. What do you think is the future of science and scientific inquiry in this country?
You have to worry, don't you, with the spending cuts being made at the moment, especially with the cuts announced to the CSIRO today, to radio astronomy and a lot of other areas. But I mean, you just have to hope films like Jurassic Park are going to be able to inspire people to go out and put more pressure on governments to spend money properly on research in universities. And yeah.
And for those who wonder, for something like this, what can we learn from these ancient bird dinosaurs, this new information? What does that tell us about where we are now and where we may be headed?
For our own evolution, you mean?
Yeah.
Yeah. I don't know if it tells us very much about our own evolution. It does tell us about the process of discovery, and it just shows that, through proper science, the amazing things that you can learn, and it's just amazing that we've been able to look to the fossil record and find from these tiny clues rebuild this whole picture of an incredible lost world.